Next thing I'm going to do is populate the resistors. You can see I have my little thing right here. It has all my resistors in them. Nothing fancy, just standard metal film resistors. Okay. So what I'm going to do is just simply start cleaning these. Again, we're going to clean each one. And I'm going to be quiet for a little bit now and just get all of these in, or this video is going to take hours, okay? But all I'm doing, to bend these, the way I've sized the board, and this isn't strictly the absolute best way to do it, but it works adequately for what we need. These are sized so that the actual bend is right up against the body, so you can just come in with your finger and just bend it like that. Now it turns out there's enough of the package here that you actually still get a nice radiused bend. We're not making sharp bends here. You don't want to make sharp bends. You want to make nice radiused bends. Okay. But sizing it like this just makes it easier for me. Number one, it takes up less space on the board, and number two, it makes it very easy to bend to get them in, which is important when you're making lots and lots of these. You know, you have to build your boards for manufacturability, of course. There we go. Okay, it's just going to take a minute. You can hear that we're actually getting them squeaky clean. That's what you want. These particular resistors are actually pretty clean. The caps I have are really dirty. They're filthy. And you'll see that when we actually get to them. You're going to be surprised at how much stuff actually comes off those caps. But now you can see why I'm really wearing gloves. If I didn't wear gloves, I'd have this. I mean, other than the cleanliness of the board, if I didn't wear gloves, I would have all this IPA on my hands. And anybody who's worked with a lot of alcohol will tell you that will dry. It's nasty. It will dry out your hands like you wouldn't believe. So it's mostly to protect me. Okay. There we go, nice and clean. This actually really does make a difference. I saw a large difference in the quality of my joint several years back when I just bit the bullet and decided to just clean everything going in. It really does make a difference. I wouldn't do it any other way anymore. You know, I don't bother too much when I'm wiring up to the box. It's really not that big of a deal in the box, but with little joints like this, you know, even small amounts of grease and dirt and junk, I see a little bit of, it's not really residue, it's just a little bit of junk that got on there from the IPA, because again, the IPA is not really perfectly pure, just like that off. What was I saying? Oh yeah, you know, with these tiny little joints, it really, even small amounts of grease and dirt and junk, you know, can screw you up. And in my shop, if the joint doesn't look good, you don't just say, it'll probably be fine. Which actually it probably would be fine. You can make shockingly bad. You know, I know because I've been inside a lot of electronics over the years. You can make some shockingly bad joints that actually work, but it's just not what we do here. Definitely don't do that here. We do it right or we don't do it. So a bad joint like that would be a rework. It wouldn't be a fatal mistake, but it would be a rework, and that just costs me time. It makes a mess. So again, we're going to come in with my magic tape, which is great. We're not going to be able to do this with the caps. But wherever you can do it, this works great. No more bending of those stupid leads. Such an awful way to do it. If you could avoid it, there's good reasons to do that. There's some NASA specs and some mill specs too, and other specs that actually call for clinched leads, which isn't just bent over. A clinched lead, actually, the lead is right down to the board, and it's actually over the trace that it's connected to. It's a very specific method of doing it. I believe that's a basic NASA spec. That's a clinched lead. The bent lead, that's not a real clinched lead. Okay. Turn it over. Again, we're going to take the time to do it right. We're going to cut all of these before we ever apply solder. There's a case or two where I don't do that when we're wiring up the chassis. It's not such a big deal on larger joints, and it's not such a big deal with wire because the wire has some flexibility to it, so you don't really get that horrible shock. But with these, you really do get quite a shock when you cut them. In fact, if you want to, you can go out. There's some companies that make what they call anti-shock cutters, and they're not talking about shock like electrical shock. They're talking about the configuration of the cutting edge is designed such that it will minimize the vibration going into the board. They're very cool. They're expensive and completely unnecessary in my opinion. All you really have to do is just cut them like this, and then the advantage to that is it makes soldering so much easier. You have to cut them anyway. Why not just cut them now? And get this forest of wires out of your way. You're always getting in the way. Why? And it's funny because you go online and you'll see people give all sorts of reasons why you should do it the other way, but there's no spec on the planet that I know of that actually that's the preferred way of doing it. But this is the internet. I'm sure somebody's going to come up with a million reasons why I'm not doing it right, and but this is how I do it, so whatever. I haven't had anything come back yet, ever. I've never had a warranty repair yet on anything. I'm sure I will one day, but still hasn't happened, so we're doing okay. Doing something right. Alright, I'm going to zoom in here now. I did put on my little headgear because I have a lot of joints to do, and I just wanted to go quickly. Okay. Let's see. Okay. Now, no more talking. We're just going to slam through these joints. We're going to do it as if we're doing it for real, which we are doing for real. I'm not sure where this board is going, but it's going somewhere. Probably tomorrow. Okay, let's do it. You'll see that sometimes, depending on the configuration of the wire and how much room I have to work with, sometimes I'll actually use the side of the iron to heat up the joint. That's perfectly okay too. Whatever you need to do. Just get heat on the joint. That's all you have to do. Just don't use that stupid chisel tip or the conical tip. They're useless. I'm sure somebody has a use for it, but you can kind of see what I'm doing here. I'm not flowing the solder in all at the same time. I'm not just globbing it on. I'm actually heating it up, heating up the joint, and then I'm sort of slowly flowing the solder in. I'm giving it a chance, number one, to wick up to the top through capillary action. Number two, it's allowing the flux to work. Again, there's flux in here. In fact, that's the smoke you see. That's not, we are nowhere near the vaporizing point of the lead and tin in this solder. We're nowhere near it. That's not solder fumes. Everybody calls them solder fumes. They're not solder fumes. What they are is flux fumes. Okay? And when that iron has stopped smoking, all of the flux is gone. So right now, see the iron, very little smoke coming off. That is more or less useless for making a solder joint right now. Okay? So I feed the solder in, not slowly, but not just jam it in there, because I want to give the flux a chance to work, and I also want to give the flux a chance to boil off and get out of the joint. We don't want flux voids in the joint. That's when you trapped flux in the joint. We don't want that. There's a proper speed. What's the proper speed? Well, it's about that. Okay. Let's see. Let's try to time this. 1, 2, 3. About 3 seconds. Okay. It's a fast joint. It's not. It's not like 1, 1, 1, 1, 1. But it's a reasonably fast joint. 5 seconds, 6 seconds. That's a little bit too slow. You're going to risk overheating parts. You're also obviously going to risk running out of flux. There's a sweet spot in there, and I'm going to show you what the flux looks like when I'm done. Okay, it's encapsulated, but it's not brown. It's not burnt. You don't want burnt flux. Okay. So you will learn what that sweet spot is as you do it. I promised I was going to shut up and do it, so let me shut up and finish this. I can tell from how the solder's flowing at the top here. I'm going to cut this just a little bit more. I can tell how the solder's flowing at the top if I'm getting a good flow, and if it's flowing to the, or really to the back of the board, if it's flowing to the front of the board. After a while, you can just tell if you're doing it right. But of course, we're going to inspect our work afterwards. Anyhow, we inspect everything that leaves the shop here. There is not one joint that gets out of this shop that hasn't been looked at and inspected. Something funny happened there. Okay. Seems like yeah, my tape didn't hold very well on that particular joint. So what I'm going to do, I'm going to come in from the, I'm just going to come in from the front. I'm going to push down with my finger, and then I'm going to reflow the solder on the back. Okay. And then what I'm going to do is I'm going to resolder it. I'm going to add a little extra solder to it so that it gets fluxed and it gets properly soldered. So I'm going to heat it up. Oops. See if we can do this without burning my hands. To heat it up, push it through. There we go. That's good. Now we'll resolder that one little bit right there. There. That's good. That's good. I can barely see the wire coming through. That'll be fine. That's acceptable. That's an acceptable joint. Okay. As long as I can see a little bit of that wire coming through, as long as I can see something. What I don't want to have happen is I don't want that to be sort of sitting inside the hole. That would be bad. You don't want that. This guy here, you probably can't see it. It's a little bit different. This one joint, the entire bottom of the board here, except for a couple of power traces, is a ground plane. What that means is that this dark green stuff here, really the light green stuff, that dark green is the board. The light green stuff is actually copper. It's all copper, and that's all ground. Okay? And the pins that attach to ground, they have what's called thermal relief on them, which means instead of the pad being put directly onto the copper, which would be fine, they have these little spokes that come out. You'll probably see it better later on, or you can look it up on the net. Okay. And the spokes are there because heating up this ground plane is really hard, even with a fantastic iron. That's a lot of copper here to heat up. If you didn't have the thermal relief, it would be very hard to solder. Still, even with the thermal relief, it still takes a little bit of extra oomph to solder these particular joints. So what I'm going to do is I'm going to do everything exactly the same way, except before I feed the solder from the other side, I'm going to give it maybe an extra second to heat up. I'll actually be able to see the solder start to flow, and then I'll feed it in. So this joint's going to take just an extra second or so to do. If you're making your own boards, when you get to those thermal reliefs, take a touch extra time, because if you don't, it probably won't flow right. So there we go. Heat it up, flow it in slowly. There we go. Done. All right. Now let's check our work. And the way we're going to check our work, we're going to rip off the tape. And let's have a look. So what I'm looking for, I'm looking to see that I don't have any burnt crispy flux. All of the flux you see here is perfectly acceptable to go out like this. This is exactly what you want to see. All the flux, there's no liquid. It's not burnt. It looks kind of glossy amber. All of the joints look nice and neat. There's no big globs. Everything is actually soldered. There's no voids. Just a general inspection, and then we'll turn it over. And see, and that's nice. We're going to check that we actually had all of the solder flow through to the top. And in this case, I didn't look, but I was pretty confident that it did, because I could tell as I was soldering. Yep. All these joints are great. There's one joint here that's okay. That joint right there, see? It didn't quite cover the entire pad. That's actually an acceptable joint. It's okay if it shrinks back a bit on the back side of the joint. What we're going to do, however, is if you find something like that, it's not a big deal. You can just come in, I'm going to check which one it is. You can just simply reheat the joint, flow in a little more solder, it'll float to the back, and voila, done. Okay. Very good. Next we're going to add our socket, our little dip socket. That's for a chip on the board, and we're going to clean it. Alright, let's start speeding up here. I keep saying that, but I don't do it. Let's find our little tape. Again, we're just going to come in with a little bit of tape. Thusly. Now, some wise guy's going to say, there's a resistor on there that I saw you didn't solder R9. Why didn't you solder on R9? You forgot to solder R9. You forgot to solder him. Well, no, I didn't. He is actually unpopulated. Had made a little bit of a wiring change somewhere else, made him unnecessary. The way I'm doing it now is better. So, no reason to respin a board just for that. It can happily stay unpopulated, believe me. It's much harder when you actually have a something that's supposed to be there that isn't. Much harder. In this particular case, we're good. Actually, I'm going to turn that sideways, because it's easier for me to solder it like that. There we go. There we go. Again, just going to, I may actually block your view a little bit. I don't know if I will. If I do, I apologize. But same exact thing. Same exact thing. When you do these plastic sockets, you want to jump around a little bit so you don't heat up one place at a time, because you will melt it. And we don't want to, because then I have to take it out and redo it, and, you know, it just takes time, and it's a pain. Okay. So here we go. Now I'm just going to do these real quick. Again, you can see I sometimes use the side of the iron. That's fine. Whatever it takes to get the joint in. Here's a ground plane. Let it heat up for a second or two, and then we'll bring it in. Same technique every time. Get a little bit of a solder bridge. I'm doing it quick. I don't know if you can see it, but I'm kind of swiping this. Kind of doing a little swipe to get a little bit of solder on the tip. Right? See that? And I'm touching the pad and the lead at the same time. Ta-da! All done. Piece of cake. Really great joints. Of course, I'll inspect them. But yeah, oh, they're really great joints. Now I'm gonna look at the top to make sure this didn't lift. I didn't melt anything. You could actually see, you're not going to be able to see it, but if you look from the side, you could actually see if solder's flowed up. And it has, but I could tell that it would, because I can tell what's happening from the back, because I've been doing this a long time, and you'll be able to tell too one day. You know, you'll just see the solder flow, and you'll be like, ah, that didn't flow right. That's not going to be good. And then you'll simply reflow it, either with flux or with a little more solder.